Assalamu alaikum students, this is Sir Shakil, A-level physics teacher. Today I'm going to solve an assessment for you because you have already, many of you are already done with this assessment and you got your result as well. There are some questions which are quite challenging in this, the others are quite on normal pattern. So I would like to solve all of them so that every one of you can look deeply into the mistakes that you have committed. So basically it's assessment physical quantities and units. It was taken on 12th of the September. Okay, first of all, you need to, there are like 10 MCQs. You need to read the MCQ very carefully. So the first one is, what is reasonable estimate of volume of fully inflated football? So for that, you know that football is in the shape of a sphere, and you know that the volume of the sphere is 4 by 3 pi r cube. So what you will be doing is you will putting the value of this radius. So you have to estimate that the radius of football is around like 10, it can be 10 to 15 centimeters. So you can use any of the value at place of r and you can work out for the answer, and the answer is B. Now you have to look for, now let's look on the second question, what is not an SI base unit? SI base unit. So we know that Kelvin is the unit of temperature, kilogram is unit of mass, second is unit of time, but this charge is the unit, coulomb is the unit of charge, which is not SI unit. Okay, moving on to the third one, which two quantities are both vectors? So displacement is vector, but distance is scalar. Force and momentum both are vector. So we will lock this answer. So our answer is B. In C, torque is vector, but time is scalar. And in D, weight is vector, but pressure is scalar. Okay, let's move forward. Okay, moving forward to next, which is the speed of the waves on the stretched rope is given by this. V is T power P and mu power Q, where T is the tension in the wire and mu is the mass per unit length of the wire. So we have to look that this T is the tension, and actually tension is equivalent to force. So we will use the units of force. And this mu is mass per unit length. So it is mass per unit length. So you'll be using M by L. So what you will be using is, you will be putting the values over there. So like V is P mu Q. So speed unit is meter per second. And you know the force units, if you don't know the force unit, just put the formula MA power P, and this is M by L power Q. And then you have to put the units. Like the mass unit is kilogram, acceleration unit is meter per second square, and it is power P, and then mass unit is kilogram, and the length unit is meter Q. Now what you will do is you will compare the indices on of similar units on both sides. So let me now compare indices of second. So on right side, the power of second is -1, and on left side it is, you know, it is minus 2p. So this negative cancel away, so p equals 1 by 2. It means the answer of p is 1 by 2. So a and b cannot be the option, and c and d can be there. Now we have to look for the other, which is q. So let's compare the indices of meter. So on left side it is 1, and on right side it is like 2p plus minus 1q, because this m is power 1. When it will go up, it will be kg m minus 1. So it is -1 into q. Now what you have to do is you have to put the value of p over there. So p is 1 over 2 and it is minus q. So 2 goes away. So it is like hold on, why I have written 2p. It's not 2p. Yeah, it's not 2p actually. It is only p, because it is kilogram meter per second square. Yeah. So so it means that this 1 over 2 will still be there, and then you will shift q to other side and 1 to other side. You will replace like 1 and q, so it will be minus 1 over 2. So minus 1 over 2 is this, so C is your option. Okay, the next question was quite simple. Which quantity is a physical quantity? So you know the feature of physical quantity that has a magnitude and unit, magnitude plus unit. If you look upon atomic number, it has got no unit. If you look upon efficiency, it has got no unit. If you look upon strain, it has got no unit, because strain we will study in AAS in topic deformation. It is change in length per unit original length, so it has got no unit. Number charge density of charge carriers, this is having a unit, because this is like number of charges per unit volume. Number has got no unit and volume has unit of meter cube. So its unit is per meter cube. So it is having the unit. That's why this is a physical quantity. Okay, let's move on to 6. What time interval is shortest? So you simply have to put the value of prefixes milli, nano, pico, and micro, and you will then see that which one of them is shortest. So B is the shortest. Simply put in the value in the calculator and then just work out for it. Like 50 nanosecond is 50 into 10 power minus 9. So it can be 0 0.1, 2, 3, 4, 5, 6, 7, and 5 seconds. So this is actually the shortest. Number 7 was a bit challenging. It is from vector addition. Okay, so P and R are the coplanar vectors. It means they are acting in the same plane. And they said if X is P minus R, which diagram best represents the vector X? So X equal P minus R, or you can say from here, X plus R equal P. Like you can shift R to other side, so X plus R. So you know the two vectors which are added are arranged according to head to tail rule. So X plus R equal P. So we say that these are arranged in head to tail rule. In head to tail rule. And this is their resultant. So now look at diagram A. X and R both like X head and R tail. They are arranged in head to tail rule. And then the tail of P is with tail of X, and tail of head of R is with head of P. So it means that this is your resultant, and the vectors which are arranged in head to tail rule, they are actually the action vectors. You add them. So it is X plus R equal P. So first diagram is fulfilled. So this is your answer. If you look at B, then you see that X and P are arranged in head to tail rule. So you will write X plus P and R is their resultant. So is this equation correct according to given one? No, it is X plus R equal to P. So this is incorrect. And both these diagrams, like these are not fulfilling, these are not the triangles, so you simply cancel them. Okay, let's move on to question number 8. A wave has a frequency of 5 gigahertz. Okay, so a wave has a frequency of 5 gigahertz. What is the time period? So you know time period is 1 over frequency, and it is 1 over 5 giga, and giga is 9. So when you solve it, your answer will be 200 picosecond. Actually, its answer is like 0.2 into 10 power minus 9, right? Now, minus 9, is nano. But if you look, this is B is 2 nanoseconds, so that cannot be option. C is 20 nanosecond, that cannot be option. So now you have to see that whether A or D is the option, A or D. So what you will do is, you will first convert it into nano. So you know how to convert it into nano. 10 power minus 9 can be written as plus 3 into minus 12, right? So we can write this, but like minus 9 is plus 3 minus 12. So minus 12 is actually pico. And when you solve this 0.2 into 1000, it will be 200. So 200 picosecond will be there. Now, question number 9. Question number 9, we have already done that in the class. C is BT cube. And they have given you the unit of specific heat capacity, so you have to tell the unit of B. So it is C equal BT cube. So unit of C is like joule per kilogram per Kelvin. B and the unit of temperature is Kelvin. Okay, so now this joule can be written as kilogram meter square per second square, because you know joule is the unit of work. Joule is the unit of work, and work is force into distance. So force is like MA into distance. So it is like kilogram meter square per second square. Okay, so then it is kilogram K minus 1. Okay, and is equal to B. It is equal to B into K cube. So you shift K to the other side, and this kilogram will be cancelled away. So it is like M2S minus 2K minus 4, right? So that's how it is option B. Now, MCQ number 10. This is from vectors. The speed of aircraft in still air is 200 kilometer per hour, and the wind speed is 85 kilometer per hour. So it is blowing, wind is blowing from west. In which direction must the pilot steer the aircraft in order to fly due north? So let's say, beta, this is like north, and you know, this is south, this is west, and this is east. So initially, finally, the aeroplane have to fly due north. So this will be like the final velocity. And then the wind is blowing from west, right? And okay, so wind is blowing from west like this. So this is wind. Of course, the aeroplane should be moving towards northwest if it has to finally move towards north, because the wind then will take it towards north. Okay, so the wind speed is given, which is 85, and the aeroplane speed is given, which is 200. So you have to tell the direction of the aeroplane, the initial direction of the aeroplane in which it will be moving, so that when the wind from the west will hit it, then it will move it along the north. So final direction should be along the north. Okay, so the thing is, you have to move this, you have to find this angle. So you know that this side is, let's say, hypotenuse, this side is base, and this side is perpendicular. Okay, so what you will do is you will use a trigonometric ratio over here, because it is right angle triangle, and you have perpendicular and hypotenuse. So which value you will be using? You'll be using sine theta. So you will say that sine theta equal perpendicular over hypotenuse, which is 85 over 200, and then theta equals sine inverse 85 over 200, and you will get the answer. And then what you will, and you will get the answer, that will be 825.2. And as it is between north and west, so that's why we will say that the answer is 25.2 west of north. Okay, number 11 was very easy. The voltage value was given and the resistance was given, and you were supposed to find current, but in picoampere. The only thing was prefixes. Like the only thing that is challenging is converting the value in prefixes. We have done that. Remember, express any value in the prefix. So you know V is IR. So from here I is V by R. So V is 0.60 and R is 4 giga. And you know giga is 10 power 9. Okay, when you will simplify it, you will you will get an answer, right? And that answer will be 0.60 divided by 4. So it is 0.15 into 10 power negative 9. Now we have to express that in pico, and you know pico is 10 power negative 12. So again, what you have to do is you have to split minus 9 into such that it become minus 12. So 0.15 into 10 power 3 into 10 power minus 12. So at place of minus 12, the pico is already written. So you will multiply 0.15 with 10 power 3, which will be 150, right? So that is 150 pico ampere. Okay, then This question was very easy. You have to find the SI base unit of potential difference. So make V as the subject. So it is energy over charge. And you know energy is like work and charge is IT and work is like F into D and it is IT. And then what you will do is you will simply put the unit to get the answer, right? That was like quite easy. At place of force, you can write mass into acceleration and then into D over IT. So then you can solve it. Let me quickly solve it. Kilogram meter per second square into meter over ampere into second. So the meter is repeated 2 times, second is repeated. So it will be like kilogram meter to A minus 1 S minus 3. You have to be very careful while dealing the indices of these values. Okay. Question number 12, electromagnetic wave has a wavelength of 85 micrometer, express it in meter. So it is like 85 into 10 power minus 6, the simplest way. Or you can write 8.5 into 10 power minus 5. So both will be correct. Then you have to calculate the frequency in terahertz. So, okay, we know that V is F lambda and F is V by lambda. So what you will do is simply put the value. So an estimation is used over here, which is speed of electromagnetic radiation, that is 3 into 10 power 8, divided by the value 85 into 10 power minus 10, right? So you will solve it to get the answer, right? And the answer is 0.035 into 10 power 18. Oh, sorry, it's not minus 10. It's actually minus 6. Okay, when it is minus 6, it will be 14. Now you have to write it in tera. So in tera, it is 0.035 into 10 power 12 into 10 power 2. So at place of 10 power 12, you are right, I've written tera and multiply 10 power 2 with 0.035. So it will be 3.5. So 3.5 terahertz. And you have to state the name of region in which of electromagnetic spectrum in which this wave is there. So that is infrared rays. So this is actually again from estimations. Okay. Then the next thing is you have to find SI base unit of stress. We will study this quantity in deformation. So stress is like pressure. Stress is like pressure. Stress is like pressure. So you know the unit of pressure, the equation of pressure. Okay, so it is like pressure is force over area and force is, you know, MA. So you will work out for it like kilogram meter per second square over meter square. So it will be kilogram per meter per second square. Okay, now this thing was challenging. Most of the students found this challenging. This is again a practice of your equation handling skills and then the conversion. So basically equation handling skill and then prefixes knowledge. These two things were used over here. So you have to find E. So first you have to make this subject. So you have to take square on both sides. So take square on both sides. Okay, beta, when you will take the square on both sides, it will be like t square is 4 pi square, and this square will be cancelling away with the square root. So it will be like this. Right? It will be like this. Okay, next step. Next step, you have to switch E to the subject. So it is E equal 4 pi square and 4 ml cube divided by t square d cube. Okay, then what you have to do is you have handled the equation. Now it's about your prefixes knowledge. So you will put the values like 4 pi square will remain as it is, and then 4 and the mass value. If you look at the mass, it is written over there 500 gram. So you have to convert that into kilograms. So it is 0.5. So you will put 0.5 value over there. And then L cube. L is the length, which is 60 centimeter, but you will convert it into meter. So that will be 0.6 meter. So it is 0.6 cube divided by what is the value of t? The value of t is given as 0.58. So it is 0.58 square. And then the value of b. So the value of b is 30 millimeters. So convert that into meter. That will be 0.03 meter. So it is 0.03. Then the value of d, which is 5 millimeter, convert that into meter, like 0.005 meter. You divide it with 1000. So 0.005 cube. When you solve it, you will get an answer which is 13.5 into 10 power 8. So 10 power 9. So 10 power 9 is actually giga. So you will not write it. So it is 13.5 gigapascal. So that's how you will solve it. Like, I have not done the calculation myself. You can do the calculation. And basically this question was about equation handling, about prefixes, and then again converting your answers into a prefix, which is gigapascal. So I hope that you have gone through it, and then you have to look on your mistakes and you have to redo that. So thank you so much, students. Inshallah, see you soon in another video. Allah Hafiz.